Hi everybody, I think this is the question that you wanted. So Casey now adds a capacitor in series with the battery and closes the switch. Casey measures the voltage across the capacitor as it charges. So if you just go back, if I just go, so there's a resistor, 3 ohms. And then if I look at that, the maximum voltage, there are two ways of doing this. The maximum voltage across the capacitor is 6 volts. And so what we're trying to do is find the time constant. So we know that time constant is R times C. We don't know, we're trying to find the capacitance, right? So the voltage after one time constant is V equals V max 1 minus e to the power of negative 1. So V max is 6 volts and times 1 minus e to the power of negative 1. If you put that in your calculator, you're going to get that equal to 3.79 volts. That is the voltage across a capacitor after one time constant. Let me see if I can draw on this. And if you look for 3.79, that's about 3.8 volts, and you go across like this and you come down, you see that the time constant is 1. Okay, I don't know if I can draw anything on this, so maybe I can. Yeah, so that's the time constant. Okay, change the color, make that red. Okay, so that's a time constant. That is for 1. So one time constant is 1 times 10 to the power of negative 5. So if I use 1 times 10 to the power of negative 5 equals, my resistance is 3 ohms, 3 times C. So then my C becomes equal to 1 times 10 to the power of negative 5 divided by, I don't know how to get the division sign on the computer, divided by 3. And then, so if you put that on the computer, if I get 1 exponent negative 5 divided by 3, I get 3.33 times 10 to the power of negative 6 times 10 to the power of negative 6 farads. And that's how you do that question. Hope that made sense.